Hello, welcome to week 14 lesson uh, 5 binomial theorem. And this week we are going to discuss about how to expand a binomial raised to a power, and also we are going to practice how to find the coefficients of the binomial expressions, and then we are going to discuss how to find a particular term in the binomial expressions. At the end of the lesson, you should be able to find the coefficients of the binomials, and also you should be able to expand a binomial raised to the power, and also you should be able to calculate a particular term in the binomial expansion. Now let's see the content of this lesson. So in this lesson, we are going to see uh, how to find the binomial coefficient using a formula. And we're going to discuss about the binomial theorem, which help us to expand a binomial raised to a power. And then we're going to discuss on how to find a particular term using binomial theorem. And as usual, at the end of each lesson, each problem, you should practice the checkpoint questions from your textbook. So this is about the lesson content. Now let's go to the key concept regarding binomial coefficient. For finding a binomial coefficient, we are going to use a formula. For n-negative integers n and r, with n greater than or equal to r, the expression n above r is called the binomial coefficient and is defined by n above r is equal to n factorial over r factorial into n minus r into n minus r factorial. Here, this is a formula for finding the coefficient of the binomial expressions. The symbol NCR can also be used in place of NR, n above R. Now using this formula, let's go to example 1. Example 1 is about evaluating binomial coefficients. In example 1, you are asked to evaluate the following binomial coefficient. In order to find the binomial coefficient, as we said earlier, we need to use the formula n above r is equal to n factorial over r factorial into n minus r factorial. For example, for case A, the value of n will be 6 and the value of r is 2. Then you just plug these values into the formula so that you'll get 6 factorial over 2 factorial into n minus 2 factorial. Simplify it and you will get 15. For B, the value of n is 3 and the value of r is 0. So plug into the formula, it will be 3 factorial over 0 factorial into 3 minus 0 factorial. Simplify it and you will get 1. For C also, the value of n is 4, the value of r is 4. And plug into the formula, then you will get 1. So this is example 1. Now let's go to the binomial theorem, which helps us to expand the binomial raised to the power. A plus b to the power of n is equal to n to 0 times a to the power of n plus n to 1 times a to the power of n minus 1 times b to the power of 1 plus n to 2 times a to the power of n minus 2 times b to the power of 2 plus, and finally it will be n to n times b to the power of n. So this is the binomial theorem that helps us to expand any binomial to the power to n. As you can see here, the degree of A it's decreased by 1 and the degree of B it's increased by 1, and the number at the bottom start from 0 and it increased by 1 and finally it will reach to n. So this is a point that you should know regarding the binomial theorem. Now based on this theorem, let's go to example 2. In example 2, you are asked to expand x plus 2 to the power of 4. The first thing that you need to do, you need to identify, or you need to point out which one is A, which one is B, and which one is N. In this case, the value of A is X, and the value of B is 2, and the value of N will be 4. Then you can easily plug these values into this formula. So it will be the value of A is X, so it will be X plus B is 2, so it will be X plus 2, N is 4, so X plus 2 to the power of 4, and N is 4, and it should be start with 0, the number at the bottom should be 0, or the value of R for the first term should be 0. Then the value of R, it will be increased by 1 till 4, and the degree of X should decrease by 1, and the degree of B, which is in this case is 2, it should be increased by 1, and finally it has to reach to the power of 4. Then you can use your calculator and simplify the expression, and finally you'll get x to the power of 4 plus 8 times x to the power of 3 plus 24x squared plus 32x plus 16. So this is example 2, and let's practice more on how to expand a binomial to the power of n. So example 3, expand 2x minus 5 to the power of 5. So here 2x minus 5 to the power of 5 is equal to 2x plus negative y to the power of 5. So the value of A will be 2x, and the value of B will be negative y, and the value of N will be 5. Then we can apply this formula, the binomial theorem formula. So just plug the value of A, 2x, in A, and the value of B, negative y, you will place in B, and N is 5, so you just plug it in N, which will be 5. So when you expand it, we need to begin with 5 to 0 times 2x to the power of 5. Then the next term, 2x, its degree should be decreased by 1, and the degree of negative y should be increased by 1, so it will be 1. And in the next term, the degree of 2x should be decreased by 1 again, it will be 5 minus 2, and the degree of negative y, it should be increased by 1, so its degree will be negative y to the power of 2. Then finally, it will reach to negative y to the power of 5. So when you simplify this expression, it will be 32 x to the power of 5 minus 80 x to the power of 4 y plus 80 x to the power of 3 times y squared minus 40 x squared y cubed plus 10x y to the power of 4 plus y to the power of y. So this is example 3. Now let's go to example 4. In example 4, there is one formula that we are going to use, which is to find the particular term in a binomial expression. You are going to use this formula, n above r times a to the power of n minus r times b to the power of r. Okay, the r plus 1th term of the expansion a plus b can be found using this formula. So for example, find the 4th term in the expansion of 3x plus 2y to the power of 7. So here what we need to do, again, we need to identify the value of a, the value of b, and the value of n, and the value of r also this time, because you are asked find the 4th term. So here r will be 3 because we are looking for r plus 1 term. Okay, so the 4th term of the expansion is r plus 1 term, thus n is equal to 7, r will be 3, a will be 3x, and b will be 2y. Then plug into the formula, n into r, a to the power of n minus r times b to the power of r, n is 7, r is 3, a is 3x to the power of 7 minus 3 times b is 2y and r is 3. So simplify the expression, and finally the fourth term will be 22,680 x to the power of 4 times y to the power of 3. So this example 4, so this is the last example. Uh, as usual, we are going to have more discussion on our live discussion on our Zoom class. If you have any question when you do the checkpoint, please you can forward your question during our live discussion. But for now, I will finish the discussion here because this is the last example. Thank you and goodbye.